Bitwise XOR. Let me first explain the question and then I try to find a solution to solve it. Yeah, so first let's check the result. So this n gonna be the derived dot less, and n would be a very big number. And let's check what we need to do. We get a derived array, and this array is get from the original array. So it will meet the formula like that. If I equal to n minus 1, derived I would be equal to original I XOR original 0. Yeah, so this means if it is at the end for this 0. So how did this value derived? So for this value 0, it is the original n minus 1 XOR original 0. So this is the first formula. Otherwise, it's gonna be original I XOR I plus 1. So for example, if it is index 0, it's gonna be 0 XOR 1. So we get a 1. So for the next one, 1 XOR 0, we got another 1. And lastly, we got a 0. Yeah. But how can we solve it easily? If we use a brute force, it is not possible. Yeah, because as you can see, it is 10 to the power of 5. It is a really big number. 2 to the power of this number, it's gonna be time limit exceeded. Yeah, because anyway, you cannot try to use the brute force to find all the combinations of the array and then check if it meets the derived. Yeah, it's gonna consume the 2 to the power of 5's time. Yeah, it means it is impossible. But normally for this XOR, we're gonna use mathematics to solve it. Yeah, first of all, let me just copy the array and try to use a mathematics to prove it. Yeah, so let me copy the array. So this is the derived array. I got a derived array. So I don't know the original array yet, but I can guess. Maybe it is AB and A or AB and B. Yeah, right? It can be because it is it can only be coming from 0 or 1. So the original array is also 0 and 1. I think it is according to the question. The original array must also be 0 and 1. Yeah, so 0 indexed array derived with less of n. Yeah, computing the bitwise of adjacent values in a binary array original. So this means the binary array, it can be ABA because we don't know if A is 0 or 1, it doesn't matter. Or we can use ABC, it doesn't matter. Yeah, but for this kind of solution, we can use AB and A. Yeah, or you can use BA, BA and B, but it doesn't matter. We just guess there might be 3 values, or maybe this is C. We don't know it yet. Yeah, so let's just make it AB and C. So for the original array, now we're gonna check this original array. So what is it gonna be? So first of all, for this 1 should be equal to A XOR B, right? And the second number, this one, yeah, the second one gonna be B XOR C, and the last number 0 gonna be C XOR A. Yeah, now we can get the result. So 1, yeah, so from the right side, we're gonna check this A XOR B. Yeah, we're gonna check because XOR can use the calculation directly. Yeah, let's just check this one with XOR the second one B and C, and with XOR the last one. Yeah, because we don't know how to solve it. Maybe we can just guess. So A XOR B, B XOR B, C A. So what's the result? So B XOR B, it is a 0. C XOR C, it is a 0. Yeah, so 0 XOR any numbers, it is the number itself. So this is still A. A XOR A, it is a 0. So this value would be 0. Now what we can get? We just need to check from this array, the derived array, if the XOR of all the numbers would be equal to 0 or not. So 1 XOR 1 XOR 0, it's gonna be 0 because 1 XOR 1, it is a 0. 0 XOR 0, it is a 0. Yeah. So now the problem just becomes, we need to check the derived array if XOR of all the numbers is 0 or not. If it is 0, we're gonna return true. If it is not, like this example, we're gonna return false. Now let me write the code. So for yeah, let me prepare a result would be equal to 0. So for n in derived, so result would be equal to XOR, result XOR with the value. Finally, we just need to return if the result equal to 0 or not. If it is equal to 0, we're gonna return true. Otherwise, we're gonna return false. Yeah, you might think why the code is so easy, but it's really difficult to think about it. Yeah, I believe you just need to practice. Yeah, because in this way, the time complexity is n, O n, 10 to the power of 5. So this is why we can pass for the Leetcode. Or maybe you can think forwardly. Yeah, but it's really difficult to think forwardly because you never know the original array. Yeah, but this is just a proof of something wrong if it is wrong, but it's not a proof of it is really true or not. Yeah. Now at least we know if the array like 1 and 1, it must be true. Yeah. But with 0, it must be false because we cannot find it. With 0, it is also true because XOR of the 3 numbers is true. With another 0, it is also true. But what about with 1? It means there will be like this gonna be 0, 0 XOR 1, it's gonna be 1. So definitely, if the array like this, it's gonna not be possible. Let's put the 1 here and 0 here. Yeah, is that possible? It is never possible. So for example, from the original array, we can guess maybe 0 and 1, maybe another one is 0. Yeah. So this gonna be the original array. Yeah. 0, 1, it is 1. 1, 0, it is 1. And the next one, definitely we're gonna try a 1. Because this number gonna be a 1. So this is if this is a 0, it has to be a 1. So it means this is not possible. Yeah. Maybe you can think about other ways. Why not? Let me put it a 1 if that's gonna be possible. Yeah, if it is a 1, definitely at this position, I have to put a 0. Yeah, because 0 and 1 should be 1. And the first position, it has to be a 1 because 1 XOR 0, it should be 1. Yeah. But what about this position? Because this value is 0, but here is 1. I cannot put a 0. I have to put a 1, right? Because 1, I have to, yeah, here I have to put a 0 because 1 XOR 0, it is 1. But what about this position? This is 0, so the last one must be 0. If this last one must be 0, 0 XOR 1, and this value cannot be 0, it must be 1. So this is another proof. Yeah, it is not possible if the result XOR of all the values is 1. It is not possible to get the result. Yeah, so there will be many different way of proofment, but this proofment is just like the reverse proofment. Yeah, it's like not forward. You just need to yeah, find a result. Maybe that is not possible, but that is important. But that is not possible. Yeah, so this means we have to use some examples to prove it. Yeah, I hope you understand. But basically, for such questions, we need to practice a lot, and we need to understand the XOR properties of any numbers. Yeah, like the same number, it's gonna be 0. Yeah, it's just used this formula. Thank you for watching. See you next time.